Welcome to our 2024 season of the Cloud Industry Forum Presents TWF show. We're speaking to you live from our mixed reality newsroom experience created by our friends here at Disruptive Live. This is our weekly video podcast where we interview a guest from our members or someone doing something cool in cloud technology or AI or transformation or leadership or something about what's coming next. I'm David Terrar. I'm the CEO of the Cloud Industry Forum, which is a not-for-profit trade body that champions and helps accelerate the adoption of cloud technology and services. If you want to find out more about us, we're at cloudindustryforum.org. I'm at DT on X, David_Terrar on Threads and Instagram, easy to find on the web and LinkedIn and the like. For today's show, we're talking to one of our forum members about an emerging technology that has profound and enormous potential, but needs some explanation to make sense of it. You know, I actually did a physics degree and had ambitions to research elementary particles before I moved into tech. But the great Danish Nobel Prize-winning physicist Niels Bohr said, "Those who are not shocked when they first come across quantum theory cannot possibly have understood it." So today's guest will help us make sense of quantum computing. She's OVHcloud's quantum lead. I'm delighted to welcome Fanny Bouton to the show. Fanny, welcome. Please, can you introduce yourself, your company, and what you do?
Hi, David. Thank you for the invitation. I'm really glad to be here today. I'm working at OVHcloud. OVHcloud is a cloud provider, European cloud provider. We are a leader in Europe. We have, it's a French company with an international presence based on backbone of data center and point of presence spread across the globe. We deliver public and private cloud products, share hosting and dedicated server solution in 140 countries worldwide. And since 21, we develop a quantum project and we start quantum solution since 22. And I think we can talk about that a bit in this next few minutes.
Excellent. Now, before we get into quantum theory and how it applies to computing, tell us a bit about your background. How did you get to be in this topic?
Yeah. First, I'm passionate about science fiction, and I read a lot of comics and watch a lot of movies talk about quantum worlds and fiction. And in 1996, I read an article about teleportation of an atom. I say, wow, maybe one day I can have a teleportation. And in 2070, Olivier Ezrati, who now write a book about quantum understanding quantum technology, comes to me. He's a friend, and he said, maybe we need to vulgarize what's happened in quantum. No one explained clearly what we have in French. Do you want to come with me to write this conference about 1 hour? And I say, okay, but we don't stay behind our computers. We need to do interviews. I was a journalist during 20 years, and I love to interview people. And we are going to start interviews people for this conference. And we start by Alain Aspect, who is now a Nobel Prize of Physics, but at this period he wasn't. And it was really interesting to start by this guy. He's fascinating and really, really amazing because he realized the entanglement of in 1984 and yeah, it's amazing world. When we start and you discover what's happened, it's a magical box. You every day you discover a new things who enlighten your brain and your neurons. And it's why I start. And now I arrive in 2020 at OVHcloud and to run a startup program. And inside this startup program, about all of type of startup, we decide to create a special program for startup in quantum.
Fantastic. Well, let's go back to the start. What is quantum computing?
Quantum computing, it's a new way to do computing. It's using the science of these small, really nanoscopic particles to do calculation. There is few things in the physics of quantum, like entanglement, but also duality of wave particles and other stuff who permit to create a new way to do the calculation. It's a bit weird at the beginning, but when you understand that, you can see the potential of this new type of calculation. The goal is to have the power to resolve very complex calculations that we can't do with our actual HPC and machines. And this is a promises for who could be realized in 10 or 20 years to develop these computers at the full power. We are just at the beginning, but we know that mathematically on the paper it works, and it's really interesting to do this journey to solve new drugs, a lot of things, very complex.
And it's so important because it can do, like you were saying, stuff that high performance computers and classical computers can't. Potentially it's much more powerful.
Yeah, there is two things. The first is we have the law of Moore's, and we know that we arrive at the end of to do more power with the computers that we have actually. We have at the end of this story, not totally the end, but we know it's complicated to do more power. We know the limits of this type of machines actually, and also because the quantum computer open a new door that this classical computing can't never do this type of calculation. It's an algorithm. It's a new opening door of new type of calculation, and who resolve they resolve this complicated calculation also. And it's why it's really interesting. It's go faster, but also open new algorithm way and resolve things that we never imagined before.
So what kind of mathematics are involved in exploiting quantum computing?
It's exploiting the linear mathematics. It's really different. Before we don't use this type of mathematics, we know them, but it was not used it because we don't have machines to use this type of mathematics, and we have so much to do with the actual one. And now, we have new algorithm arrive to run on these future quantum computers, and it's really interesting to see what's happened because its advantage. It's not only for in 20 years when we have the full capacity of quantum computing. It's we can see advantage with a small part of these algorithms running in a hybrid classical and small quantum computers also. And we can see we have different steps during this journey to go to this full power.
So we've got, you were talking about the future in 20 years' time, but you're also saying that we've got quantum computers that are actually in production doing good stuff now.
Yeah, actually, we have. It's also another thing that it's we don't know what is the best particles, the best component to do quantum computers. Actually, around the world, there is around 10 materials using to do these quantum computers. Like at the beginning of the classical computing, actually, we know that we have all silicium transistor in our phones, and computers. But at the beginning, we use a lot of things to do 0 and 1 in our to do classical computing. We use lamp, water, and silicium. And silicium was the best to scale and to put in the industry the best ratio cost performance. And it's why actually we have this only one materials to do all the transistor and CPU in actual materials. But in quantum computing, we need to choose what is the best. And actually, we have a lot of startups around the world who try photons, cold atoms. You have so many techniques and materials. And there are smalls. It's 2 qubits to 117 qubits. I think IBM actually is the most advanced. But in France, for example, we have six materials with it and 6 startups who develop quantum computers. And actually, a startup like Pascal, who use neutral atoms, they are around 100 qubits. It's really small one. It's just the beginning, but we can start to run algorithm on that machines and use it with in hybrid calculation with HPC. And it's starting the journey. It's like to run a cart and to want to drive one day a Formula One.
Got it. So what kind of industries, what kind of problems is quantum computing going to help?
It's all optimization and simulation problems actually, and maybe accelerate the learning machine in AI. But yeah, it's all simulation and optimization problem. It's really complex problem, and imagine optimization of a very complex trajectory. Or if you have more than 8 shops in the world and 200 products to send references of products, and up to 8 shops in the world, it can be resolved by classical machines. It's how to optimize the trajectory and the price and of that. For example, it's a good start, and we have so many problems more complex, like 200 people at the weddings, and to do the best table for it's really complex for human, but it's more for machines. And imagine if you can optimize for the traffic of automobile in a full city with thousands of cars and more than 10 lights to change and to have better ways or Google Maps.
So that's fascinating because that kind of optimization problem is there in so many industries. So that would be like things like drug discovery, and obviously you mentioned the retail side of things, optimizing supply chain, all sorts of things. It's potentially incredibly useful. And obviously you mentioned artificial intelligence. You're saying that potentially it could accelerate generative AI type problems too.
Yeah, it's obviously it's all industry can be one day interested by quantum computing. Actually, a lot of people wait that it works. It's working. It just understand that it's now we need to start to organize people, to train people, because it's it's complex, and we need time to understand and have a good team who understand what's happened and find the good use cases to optimize. But yeah, all industry are involved in that in the next months. I would like to say, if it's not years. Yeah, and for simulation, same. It's simulate new materials, simulate trajectory. So many things to do, and are not solved by classical computing. It can be really interesting in the next years.
Am I right in thinking, because you mentioned classical computing a few times there, that actually quantum computing is always going to work in conjunction with classical computing to help make it work?
Yeah, for example, you can have actually that we can't run a complex algorithms because we don't have the power of millions of qubits intricated and stable. But we can do the hybrid calculation. One of the part of the algorithm can be pushed on a small quantum computers, and the other part on a classical HPC. And you have not already an advantage, but we can see that in next months or 2 years, we have advantage like just running on HPC. For an example, a bank in France, Crédit Agricole, start 2 years ago a POC, a proof of concept with Pascal. They use a smaller data set of for to have these results, and in the same time that in a HPC they obtain the same results. It's not an advantage in time calculation, but it's in energetic powers, because you use the Pascal quantum computer use less power actually than a HPC for the same results and same time. And it's really interesting to see that. It's not for all the type of algorithms, but it's interesting that we can do that for a part of algorithms, and it's a good start to have advantage.
Excellent. Now, your OVHcloud, how does cloud work with quantum computing?
It's a good question. Cloud is it will be and it's at the center of quantum computing, because for a few reasons. The first one, it's a quantum computer is really expensive. It's not cheap, and if you can share the price of the machine at many clients, they share the price also of the machines of the computer, and it's important to give access to the most people that we can prepare the future. It's the opportunity to open to all type of clients, and they can pay to the access at the hour of the time that they use for an algorithms. The other, it's also really important, and OVHcloud decide to offer the access to this freely for students with partnership with school. It's to offer the opportunities that we have European solution, because we are lucky. We have 6 but 10 startups in Europe who are doing quantum computer. It's to use it and discover this European technology freely. And the other one, it's also if you share and these resources, it's also ecological. If you buy just one machine but you use it a few hours per day, we know that it's not good. It was the case for the HPC previously, a few years ago. Every big brand buy a computer HPC very expensive, but they don't use and they don't share these resources. And we know that it's really better to share, and through the cloud, it's possible.
Now, you mentioned staying ahead in Europe there, Fanny. I know that our government, the UK, has a quantum strategy and is setting up quantum hubs. I guess the same thing's happening in the EU as well.
Yeah, there is since a few years a quantum flagship. There is also the project of OVHPC, and each government also have their own plan. For example, in France, in 21, they start also a plan of 1.8 billions of euro to help this ecosystem of quantum start in Europe. And I think we have other announcements in the next months because the first part was really accelerated, and now we need to push the second part. But yeah, Europe is really involved in quantum, and UK is definitely a part of that. You have a very good school and program also. It's we can't blush about what's happened, because if we watch what's happened worldwide, we have the governments of and the Europe is involved in money, but also in technology, in school. The lack can be arrive about the investment, and we need to be careful because US or China can push a lot of money in investment, and we can be shy. It's not by the government, but by our venture capitals. And how to solve that? It's to involve the industry, the company, to start the R&D and to put money in the quantum field. Octave Klaba, our founder, said each company who win 1 billion need to push 1 million in R&D and quantum now to don't have the mofo of quantum. It's really important.
It's important that we invest and we stay ahead. Now, next question is do you think that there's going to be a kind of like a something big that's going to move quantum computing forward, like kind of like 16 months ago with the kind of the moment that happened with artificial intelligence? Can you see the same kind of ramp up happening so that quantum computing becomes more mainstream?
Actually, it's a bit different. I think we don't have. We have a quantum hype actually, and it's but and we need to be careful to don't give false hope. This is a long marathon journey. We know that it's the big results will be in 10 or 15 years to have the full power of quantum computing. But it's also important to understand that it's now that we start. It's a long journey also to learn and to prepare the company. And it can be cheap. You can start the journey by using emulators. It's software who emulates the comportment of quantum computers. Actually, at OVHcloud, we have five emulators from 5 startup and French company, but we continue to develop, and we have few announcements during France Quantum. It's really important to start this journey now, to understand, find the use cases, work the algorithms. You can't drive a Formula One if you buy one now. You go in the world. You need to learn how to use it and prepare all the strategy to win the race. And there is a quantum hype, and it's important to use it, but at the good way. It's you don't do money in the short terms, definitely, but in the long term, you can't miss it. And if you miss now the beginning, you need to pay the other to do for you the job, and you need to have a lot of money. I think invest at the beginning, step by step, can be really more efficient.
So that's your recommendation for our audience to get educated and to start so that you can catch the wave.
Yeah, don't hesitate to find one or two people who are interested in your company. It's also a good advertisement for your teams, because they need challenge, and quantum computing is really good for the brain, and it's good to acquire talents in your company. And it's working to a few interns to help, just to play and discover. But it's definitely good for company to go on this way and to understand what's happened. It's a big change in the future, definitely.
Well, that's been really good, Fanny. If people want to find out more about you, about quantum computing, about what OVHcloud are doing, where do they look?
Actually, you can look on our website. You have a quantum part, and you can find the 5 notebooks, the 5 emulators. It's really easy, and it's less than €2 per hour. It's really accessible to start to learn. And after, if you want to play more, we have bought a quantum computer of Candela. It's 2 qubits. It's a small one, but it's actually we work on it for our own R&D. And it's also open. If you ask in our labs, you can have a file to access to these machines, and we have also Captiva machine from Eviden. It's a hardware who emulates 38 qubits of different type of quantum computers, and it's also a good way to continue after the emulators to have more qubit accessible to see how works the algorithms, and if you are in the good way. And few announcements in the next months. Definitely, this is the beginning.
Excellent. Well, I'm still shocked by quantum theory, but that's been fascinating to have you explain it all to us. So thank you so much for coming on the show.
Thank you for the invitation, really.
Well, I hope you enjoyed Fanny's explanation of quantum computing and the enormous potential it has for so many different industries and for solving big problems. I agree with Fanny. Get yourself educated and consider piloting some ideas to help your business stay ahead of this wave that's coming. We'll be back live next Wednesday at 2:30, 14:30 UK time. We want your feedback. We want your suggestions. Maybe you want to be a guest on the show. Put something in the comments here or email us at info@cloudindustryforum.org. We look forward to hearing from you, and we hope to see you next week or next time.